Final session of the day, where we're going to talk about machine learning and regulation and blockchain and the government. So first, I'd like to introduce Jitinder Kohli. He's the Managing Director of the Government and Public Sector Strategy Practice in Deloitte Consulting. He's a globally recognized specialist who spent years working in the British government, which he'll talk more about later. And I'd also like to introduce Matthew Gracie, and he's the Senior Manager of Strategy and Analytics at Deloitte. And Matt is in a practice that supports civilian, defense, national security, health sector agencies, and they gain insight from unstructured data, such as regulations, to better serve their mission. And he has 30 years of experience in financial services and consulting. And Jitinder and Matthew are going to talk about machine learning to create a regulatory overlap map. Then I'd like to introduce to you Kevin Werbach. Kevin is the Associate Professor of Legal Studies and Business Ethics at the Wharton School. His work focuses on the intersection of business, policy, and emerging technologies. He served in the Obama administration, as well as the Clinton administration, the FCC, the Department of Commerce, and he founded the Supernova Group. He teaches a mass open online course, or MOOC, with over 300,050 enrollments. Sorry about that. And he's going to talk about using blockchain to solve government problems. So without further ado, I'm going to turn it over to Jitinder and Matthew.
Wonderful, thank you. So here we are at the end of a Friday afternoon, and we're going to talk a bit about the future and how technology can really help policymakers. So just to introduce myself a little bit more, my name is Jitinder Kohli, work for Deloitte Consulting based here in Washington, D.C., but as you will tell from the accent, certainly grew up in another country, worked in the British government for most of my career. And before we talk about technology in the future, I'm going to do a little history. So between 2005 and 2009, I served in the British government as the person responsible for regulatory control. The equivalent job in the United States is the head of the Office of Information and Regulatory Affairs in the White House, the OIRA role. So I served in that role in the British government. It was actually a career role. We don't have very many politicals in our government, so some differences in our countries. And in that period, we were going through, I worked for a Labour government, and our government had an absolute commitment to finding ways to reduce the cost of regulation whilst maintaining protections, and a commitment to getting those two things to happen at the same time. So we launched a pretty serious initiative to look for ways to reduce costs, and over a 5-year period, we did hundreds and hundreds of initiatives around agencies in government, and as a result of that, took out about $5 billion worth of cost for business, which, to get to a US number, you might multiply that by about 10. It was about 0.6% of UK GDP at that point in time. But we did it in a very manual way. Like, we did it by, counting all the, getting all the regulations, looking at them individually, and it's a very human way that we did that. I've been in the US for about 10 years, spent 3 years at the Center for American Progress as a senior fellow, now work at Deloitte, and I came across some of my colleagues who understand computers 1,000 times better than I ever will, and said, well, actually, maybe we don't need to do this in a manual way. Maybe you could do it in a very different way. So I'm going to hand over to Matt, who's going to talk about the possibilities.
Thank you, Jitinder, very much. And so this is the Technology Gets Fun section of our day. And I realised this morning that I think I only have one thing in common with Steve Ballmer, and that is we also ingest public data and analyse it and make it available completely objectively. And that's really what we're going to show you today. I think that's where Steve and I end. So what we want to show you is a thing called the Regulatory Explorer tool. But just to sort of set the scene for you, right now you could go on your phone, on your computer, and look up the ECFR, which is the Federal Code of Regulation. And you'll see how it's presented. And there's a lot of information there. If you're looking at regulation and you know what you're looking for, you can find that information. And for today's demonstration, what we're going to do is I've decided that we all like the outdoors and we're all keen to go outdoors because we've been here all day. And for most of us, like me, you'll probably like animals, so we're going to go with fisheries and wildlife for our presentation here this afternoon. And if I knew what I was looking for in fisheries and wildlife, I would know that it was Title 50. And if I was looking for particular issues around endangered species, I'd also know it was Volume 2, and it was Section 17.XX would be the section I was looking for. And of course I would know that because, well, we would all know that. But the information is definitely there. But using machine learning and advanced technology, we can get to this data more simply. And quite frankly, some of the techniques that we're applying here are similar to the ones that you saw this morning that Steve was showing us. So the Regulatory Explorer tool is simply that. It's ingested the code of federal regulation. We also ingest code from various states and other countries as well. And you log on to the system and you choose the data which you're looking for. We're going to look at the corpus of the United States for this afternoon. There's 217 sections of code. And here we go. Here we are in the Discovery view. And I've chosen, as I said before, the Department of Interior. And already using, again, the tool and the machine learning, what we've been able to find is that nearly 80% of the Department of Interior's code has actually never been edited. You can actually see over here all the various sub-agencies which could be important to you, and we'll look at those in a minute, and you can actually see when those codes were actually created. So there's some information interesting here. The last time they were edited, the average time. So the average time since they were created was nearly 28, on average was 28 years ago. So let's drill down this in a little bit further, and we can have a look here at fisheries and wildlife. Interestingly, fisheries and wildlife code generally is a little bit newer, and actually there's been some significant updating in the last 5 years, which is interesting information which we can click on, and of course we could go and find that particular code if that's the mode that we were in. We can also, again, using machine learning, we can actually cluster the various topics. So what the machine has done, it has read all the material, all the code, and said, hey, here are the various topics that look similar. If we look at this particular chart, the higher up the chart we go, the older the cluster, and the further to the right, the more similar the cluster is. We're going to have a look at this one just right here, which I've highlighted, and you can see it actually is bringing back all the code. There's actually, I think, 19 different sections of the code in there that the machine learning is saying is quite similar, and I can actually now scroll through those. Once I find the one that I'm interested in, I can actually dig a little bit further. And so here we go. By magic, we've just found Title 50, Section 17.22, and in here, and it's actually telling us about the section. You can actually read all of that, and also have a look at other sections that are very similar to it. Again, the key to understanding this technology is in the name. It's Regulatory Explorer. It's not regulatory, it's solved all the problems, or it's done all the work for you. What it's doing, as Jitinder was saying, it is doing a lot of the manual work up front. It is making the connections. It's getting machine learning to make the connections so that I can apply my time, my high value time, in analysing and understanding. So things like similarity analysis is guiding me through this process. It's guiding me and helping me try to understand what type of regulation might be similar, which might give me opportunities to look at editing, to look at potential conflicts in the various sections which may exist. The other section here, which is also quite neat, is actually now using a neural network, we've actually been able to understand the citations that are referenced in each particular section of regulation. So this is our target regulation, this one in orange here, And these sections here are the ones that it's cited but are older than it. The ones here in green, for those of you who can see, are the ones that are cited by that section but are newer than it. So effectively what we've done, we've sort of created the ancestry.com of those particular sections. Really important, because if I decide to make a change here, I can now see the impact and implications of that change across those sections that are similar. And of course, in a couple of clicks, the technology has done this for us. I'm going to move on because there's another view. There's another way I can get at this. I can actually look at the entire corpus of the Federal Code of Regulation, and I can actually ask it to look for, using keyword search, I can actually look for, in this case, endangered species, and ask it to bring back any agency regulation that might be related to that. No surprising, the Department of Interior and the Department of Commerce are showing up as the top two, and it might also, particularly if for those who read yesterday's announcement from the administration, it might come as no surprise that Fisheries and Wildlife and the National Marine Fisheries Service are actually quite prominent in this as well. We'll move forward because I can then look at these two departments side by side, the Interior and Commerce, and I can then understand what their sections, their particular sections are, but again, I can also look for different search terms, in this case endangered, and see where the clusters are. So if I was at that agency or either of those agencies, and I've now got perhaps the mandate to look at where regulation is the same or similar, or I want to look for opportunities for efficiency, this tool is actually starting to bring that together. So now I've got all in this particular instance, all the clusters of regulation across these two departments relative to endangered. And if I just move here, I can then click on those and start actually bringing back the actual sections themselves in this comparison view. So quite simply, what we've done here with this tool is been able to do a lot of the manual work. Quite frankly, the human brain's ability to understand that this section over here relates to that section over there in 217 sections is quite frankly impossible. This is why this technology was created, and this is why it exists. So we commend this to you from the standpoint of understanding how we can get into regulation in a much more efficient way and then start applying our own subject matter expertise faster to the problems that we're trying to solve in this space. And with that, I'll hand back to Jitinder. Thank you.
Wonderful. Thank you very much, Matt. So what does that all mean for policymakers, and what can policymakers do? So what does that mean for policymakers, and what can policymakers do to use technology like this? And I'd say that if you're a policymaker and you're sitting in an agency, or if you're sitting on the Hill and you're looking for ways to deconflict regulation, you're looking for ways to eliminate duplicatory regulation or eliminate burdens that may be unnecessary and don't provide protection, this would allow you to do that much, 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 much faster than the old methods that we were deploying in the UK. And the methods we deployed in the UK weren't just deployed in the UK, they were also deployed by a number of other nations around the world. The Netherlands, Denmark come to mind, and a number of other countries we're working on that all at the same time. Canada, Australia are countries that are right now working on regulatory simplification. So a couple of lessons from those countries that I wanted to share. One of them was that in the UK, certainly, we placed a dual emphasis on protections at the same time as reducing burden. And what that meant is we were able to build a lasting coalition committed to eliminating burdens where they were unnecessary. So, for example, all the work we were doing in the UK, we were doing collectively with trade unions and consumer groups, and we were getting their buy-in for the work that we were doing. So that's one thing to think about in the United States as the US kind of embarks on this journey. Secondly, I'd say another thing that we learned from the UK is that when government claims savings in terms of we've saved business this much money, then actually people are reasonable and rightly questioning those numbers. And people want validation that those numbers are true. And in the UK, we certainly found that we had to set up an apparatus to allow us to do that validation. So that's another area where, as the US embarks on the journey to do this kind of work, it may want to think about whether that kind of apparatus is worth building and how to do that. And the third area I'd say is a number of countries around the world, including the United States, have actually got a tradition whenever you bring in a new regulatory idea of trying to assess the benefits and cost of that new regulatory idea. That's an incredibly important tradition. It's a tradition that means you only bring in regulations when the benefits justify the costs, and you have to stop and think about what those benefits are and what those costs are. And yet one thing the US has done that for longer than many nations around the world. But one thing that I'd say is different about the United States and other countries is the US only does that for regulations, and it does not do that for legislation. And certainly sitting on the Hill today, that's something the US might want to think about. In a world where the European Parliament and the British Parliament both are able to provide estimates of likely costs and benefits for legislative proposals at the pre-regulatory stage, that's one of the things that the US doesn't do right now and may be worth thinking about. So I think there's a kind of twin focus between, using technology to help you find ways to do things better, and always thinking about that policy lens about how as policymakers we can really advance this world whilst maintaining protections. So I'll stop there and hand over to Kevin.
Great, thank you very much. So I'm here at the end of the day, I think, because as you all probably know by now, it's now a statutory requirement that every discussion about solutions to our nation and the world's problems has to have at least one wild-eyed blockchain enthusiast as part of it. So I'm going to try to give you a picture of why, even though blockchain and cryptocurrencies are in fact probably the most overhyped technology of our time, they are also the most significant fundamental advance in digital platforms since the internet. So I can just get the slides up. There we go. I worked at the FCC. I ran internet policy at the FCC back in the late 1990s when the internet and the dot-com boom was just taking off. And in many ways, the parallels are striking. This is a new infrastructure baseline technology that can lead to lots of benefits, also has lots of problems. Blockchain is now the source of a great deal of fraud, of illegal activity, and of regulatory arbitrage. But is also sparking innovation across the world in all sorts of different areas. So I'm going to talk with you briefly about just what blockchain is, to understand at a foundational level what the real innovation is here, and then explore some of the implications and some of the opportunities for the public sector, some of the areas where we're starting to see experiments and pilots going on. At bottom, blockchain is not about money. Even though this is the technology underlying Bitcoin and other cryptocurrencies, and it's not fundamentally about destroying governments and replacing them with purely private, decentralized systems, even though it is a system that creates a new kind of decentralized infrastructure. Fundamentally, blockchain is about something deeper than all of that. It's about trust. It's about what I call in the book I have coming out later this year, a new architecture of trust. The basic idea of blockchain is that you can trust a system as a whole without necessarily trusting any individual actor. So blockchains are networks. A blockchain is a distributed ledger. A ledger is just a database. It's a record of transactions. And the idea is anyone on that network can have their own copy of information. They can have total control over their data, have their own copy, and yet be sure and actually confident based on mathematical structures of cryptography that every copy is the same. that even though there's no master copy, that even though there's no central intermediary, everyone has their own copy of the ledger, all those copies of the ledger are identical. So that's how Bitcoin works. Bitcoin is a ledger of transactions, and even though there is no central government or central bank in the middle, all the participants on our network are able to have confidence, to trust the values of Bitcoin and where the state of the Bitcoin is in that system at any given moment. Now, there are a family of different technologies that are used to do this. Part of what's challenging technically in describing this is there actually are a number of different approaches, but they all share this basic notion. Albert Wenger, who is a venture capitalist at Union Square Ventures, talks about it as being logically centralized but organizationally decentralized. There's just one ledger. There's literally just one record that everyone is working off of, yet that ledger is distributed. Everyone can maintain their own copy, even across different organizations and across different countries. And this seemingly basic abstract idea is what has led to all of the excitement and adoption around blockchain and cryptocurrencies. Numbers that you're probably familiar with, Bitcoin being worth north of $100 billion, cryptocurrencies in general on the order of $300 billion, companies issuing these cryptocurrency tokens as what are called initial coin offerings, raising significant amounts of capital from investors all around the world, and many companies all around the world trying to employ this technology in a wide range of applications. That's tremendously exciting, but as I've already said, it's incredibly early. This is not a mature technology. There's great uncertainty. There are all sorts of problems, even basic technical problems that need to be worked out, and there are all sorts of non-valuable applications, people using this, for example, to commit fraud or using this capability to engage in money laundering and illegal transactions, and all sorts of regulatory uncertainties. Those are the things actually that I work on as a legal scholar at Wharton. Despite all of that, these are indications that we are early, not indications that this technology is fundamentally flawed or is fundamentally fraudulent or a Ponzi scheme at the heart. The reason is that blockchain has two huge basic applications, two basic value propositions. There is virtually nothing you can do with a blockchain that in theory you can't do with some other kind of traditional centralized database. However, there are large swaths of activity where no database will actually get deployed or will actually be successful because of basic trust problems. Comes back to what I talked about involving trust. And there really are two aspects of this. The first is trust minimization. In transactions, trust is a cost, right? If we didn't have trust in any kind of transaction, then we wouldn't transact. You wouldn't know that the other party would follow through. So trust is something that requires investment. It is a cost to make that transaction happen. And the idea is minimizing trust can reduce those costs and lead to more efficiencies. So there is a community that is behind some of the cryptocurrencies, that was early on behind Bitcoin, that is focused on taking governments out of monetary policy. But we don't need to distrust government and the state to see the value of minimizing trust. Any intermediary that is trusted becomes powerful and becomes a source of dependency. So take the Equifax hack. Obviously, part of the issue was the fact that Equifax got hacked and those 150 million people's records were stolen. But the fact was that that centralized intermediary, the credit bureau, had all of that data to begin with and was responsible for having to keep it secure. That's a trusted entity. So if we could design systems that would achieve the benefits, the point of Equifax and credit bureaus is not to have credit bureaus, it's to have a mechanism so that a distributed world of actors, companies and individuals can engage in loan transactions with some sense of what people's creditworthiness is. That could be done without the central trusted intermediaries. It would be much more secure and be much more efficient. Anytime there is a central intermediary, it's a kind of monopoly. It tends to warp transactions for its own benefit. So there are all sorts of applications where we want to minimize trust, but there's another side as well. Sometimes trust is too limited. Anytime transactions cross organizational boundaries, trust becomes a problem. The gap in trust actually becomes a problem. Any organization can trust what happens within its 4 walls. But what if you do a transaction with another company? Well, Typically, each side's not going to trust the other. They're going to have to maintain their own copy of the data. Again, one transaction, but 2 copies, or if it's a more complex chain, many more copies, and then synchronize them, reconcile them back and forth after the fact. That leads to delays, duplication, and errors. So you can think about, for example, supply chains, where goods and services are flowing all around the world between dozens and dozens of different organizations. The problem is the participants in that supply chain don't trust each other. They transact with one another. They'll all say, well, here's my application programming interface. You can connect into my database, but they're not willing to share the data with each other. One of the companies that did some of the early experimentation in investing in this blockchain approach is Walmart. They started with food safety. And again, Walmart is incredibly good at this. They're one of the best companies in the world in supply chain management. They said, well, how long would it take us to figure out if someone got sick buying something at Walmart, what farm grew that produce? 6.5 days, how long it would take them to figure out what farm it came from. The idea is if you can put that on a shared ledger, this one distributed platform that everyone has access to becomes much more efficient. In Walmart's case, they got the 6.5 days down to about 2.2 seconds, having it on a blockchain ledger. The other potential is everything is on one shared ledger, makes it possible to use as a platform and build what are called smart contracts, automated software applications on top of that ledger, and it makes auditability much easier. And in fact, auditability can be embedded in the processes itself. Because again, everyone is seeing the same ledger, so an audit is not something that has to come in by a third party forensically. The transactional data can be readily available directly on the blockchain itself, including to regulators. And what this has led to, roughly corresponding to those 2 categories, are 2 broad approaches. And again, there are different technical mechanisms underpinning this, which I don't have time to get into. But one class of systems are crypto economic systems that use a cryptocurrency, a token like Bitcoin, as an incentive structure. These are the outputs of the system, but they're also the inputs. Bitcoin depends on Bitcoin to incentivize miners who are investing the resources to secure and validate transactions on the network. So the tokens actually become an incentive for behavior. That's one category of applications. The other category are what are called permission systems. If you know who's on the network, if you know who all the parties are, you don't need all the overhead of that mining and validation process. You can create a shared environment. No one's in control, still decentralized, but much more efficiently use that shared ledger. So let me talk about some of the applications of this, in particular for government. The reality is we're at a time when trust in government is at an all-time low. And so systems that minimize trust have tremendous potential. And we're at a time when government resources are incredibly constrained. And these blockchain-based solutions tend to be open source. They involve shared infrastructure and shared software. They tend to be incredibly secure systems, again, because they decentralize out this process of security and create an alignment of incentives to secure the network. And they're designed around an information security and cryptography paradigm that puts security at the core. And again, they allow for this integral accountability in the system itself. And there are many reasons why governments want to do this, including the fact that the reality is governments want to show that they are tech savvy. They want to attract capital and attract innovation and attract startups to their localities. But also governments want to be a platform. This notion that the government infrastructure can be a ledger layer at the bottom and then software functionality runs on top of it is very powerful. So let me very quickly run through a few examples and then I'll wrap up. Much of what governments do is about record keeping. Canonical official systems for records. These can be put on blockchains, making them more secure and more accessible. So Cook County in Illinois, the area around Chicago, has run an experiment putting land title registration on a blockchain, making it immutably secure. Once information is recorded on the blockchain, no one has the power to change that information. And again, potentially being the foundation for these smart contracts. So when there are liens on properties or other needs to add additional information, that can be layered on top in the same system. On the right is the former governor of Delaware announcing something called the Delaware Blockchain Initiative. Delaware changed its corporate law and built a system for corporate share issuance. Basically, when you buy a stock in a company, you don't actually own that stock. It's technically actually owned by an intermediary called the Depository Trust and Clearing Corporation, because if you actually own that stock, the system would grind to a halt because you'd have to trade the physical stock certificates back and forth each time. So there's an intermediary, but again, the intermediary has to be trusted, and the intermediary can't keep up with all of the transactions. So Delaware's created this platform for the share issuance of companies to actually happen on the blockchain. So then a company can actually see its cap table, all of its investors in real time. Second category is voting, where there's two big interests leading to lots of experimentation. One is security, obviously huge issues around election security, and the second one is access. So West Virginia just did a trial recently for their recent primary, where they did this for service members deployed overseas. If someone's on an aircraft carrier, it's hard to get them an absentee ballot to vote in the primary. So they had a vendor create a blockchain-based system that you could access with a mobile device and use it to securely cast a vote that will be recorded on the blockchain. So this potentially uses this immutable security of the blockchain as well as the native digital accessibility. This one, though, is one where honestly most information security and election security experts are extremely concerned about. Because the question is, where's the real challenge? Is the problem of information security in elections the core record, or is it all the things around the edges? And the blockchain may be perfectly secure, but if there's malware on your mobile phone that you're using to cast a ballot, so you push the button for the Republican and the vote gets recorded as the Democrat, blockchain at the core doesn't necessarily solve that problem. So this is one of the examples where there's early interesting experimentation going on, but we need to see really if this new system solves a real problem. Third one is efficient provision of services. The blockchain architecture, again, because everything gets on one ledger, can eliminate the need for intermediaries, which can add cost and add complexity to systems. So this is a pilot program done by the UN World Food Program. They are providing cash transfers to 100,000 Syrian refugees in refugee camps in Jordan, where they need to provide them with these direct cash transfers that they can then spend at stores in the refugee camps. And they're doing it by recording that on a blockchain ledger. Makes it incredibly secure, and again, provides this foundational platform. Right now, it's just the UN World Food Program running this blockchain, but they can then bring in other organizations, even private actors, and layer on additional functionality where the people are in control of their information and it's on a decentralized ledger. And this kind of mechanism can be used for any kind of government procurement system or the process of providing services and providing value out to people. Fourth one is compliance, similar to what you just heard about. There is great potential in the field of RegTech, regulatory technology. And blockchain, first of all, eliminates some of the intermediaries. So I've got a workflow here about a tax example, where in the traditional system, many intermediaries and steps that need to be gone through in the process of tax collection. Putting it all on one ledger potentially eliminates those. And it also creates this environment, again, where regulators can get direct access to the transactional data. Because, again, there's just one ledger. And so this potentially has great potential for a whole variety of regulatory contexts where, again, traditionally the process of keeping track of activity was something that had to happen after the fact. And finally, there is tremendous experimentation in new kinds of applications. So I put up here a link to the city of Berkeley, California, is going to use blockchain to issue micro bonds, municipal bonds for a couple $1,000s at a time. Because blockchain-based systems using cryptocurrencies don't require centralized intermediaries, the value transfer happens directly, potentially allows for much more efficient transactions and allows for much smaller value transactions with direct maintenance and tracking of the information. These smart contracts, these basically automatically operating software applications on the blockchain, can be used to manage and track and implement the interest rate process and the repayment process and the securitization process of these bonds. So that's just one example. There are experiments around Internet of Things. experiments around electricity, microgrid trading, where again, the idea is putting everything on a platform and then allowing software applications on top of it makes government into a platform for new kinds of innovation. And there is a tremendous amount of this experimentation going on all around the world. I put up a Deloitte chart here, not for these guys. It's the best one I could find, even though it's about a year out of date, just showing some of the different experiments in many different jurisdictions in this area. Now, to wrap up, it's still incredibly early. Many of these will fail. But if you could go back to 25 years ago, early 1990s, and you knew what the internet was going to become, not just for the private sector, but pretty much everything that we've been talking about this whole day has to do with either government making data available over the internet or government systems which are accessible over the internet. It's been incredibly transformative across both the private sector and the public sector. So if you knew that kind of innovation was coming, what kind of bets would you make? Took 20 years for all this to unfold. Something similar will happen with blockchain, but we're at that point now where we can start to see the potential. And so therefore, this is the time for public sector agencies, as well as enterprises in the private sector, to start to experiment and figure out where the real opportunities are, where this technology can actually solve problems in new kinds of ways. So that's where we are today, and it's a very exciting time. Thanks very much.
Thank you for presenting. That was really inspiring. I want to invite everyone who has questions to come up to the mic. I'm going to start off with a few that were given to me from the audience while you were speaking. So blockchain seems, at least the way it is today, that it requires a lot of data storage and computing power. What do you think are the probabilities that it can scale efficiently?
Scaling is one of those technical challenges that I alluded to, where there's a great deal of fundamental computer science work being done on it. But this is where it's important to distinguish, as I did, between Bitcoin, these what are called crypto economic systems, and the larger blockchain technology. So systems like Bitcoin, because they're open and accessible to anyone, use this process called proof of work or something similar, which is the mining process, where people spend literally billions of dollars a year and huge amounts of electricity to compete to verify these transactions. And there are big scaling challenges with that. There are big environmental challenges with that, about all the power that gets used. So there is a great deal of work going on to create new systems that are similarly secure, but don't have those limitations. And at the same time, there are these permission systems. Again, if you know who's on the network, if you're Walmart, you know everyone in your supply chain. You're not just going to say, well, anyone in the world could show up and be part of my supply chain. If you know that, you actually don't need to do all that proof of work. You can use different kinds of algorithms that don't have all those limitations. So it comes down to a question of what technical trade-offs you want to make and how important scaling is. But long term, absolutely, I'm optimistic that the limitations that are there now are not permanent problems.
Thank you. And this is to Matthew and Jitinder. So can you tell us a little bit more about the machine learning methods that you use to create the regulatory map?
There's a technical person in the room. We appreciate that. We're using natural language processing tools and open source code primarily for those who are particularly interested in that, and we can certainly we can talk a lot more in depth about those things. I think I'd like to address that more importantly by saying that these are commercially readily available tools, and they're very accessible. They're very accessible to the data science community, it's really about how you apply those tools and work with the subject matter experts. We like to say, our data scientists sitting next to subject matter experts is where the value of these types of tools really rests. So, I certainly wouldn't want to create the impression that there's a particular magic or even proprietorship to what we've done here, other than, quite frankly, as Steve and his team have done, is taken publicly available data and applied tools to look at it in a different way and do activities against that data that, quite frankly, humans don't need to do anymore. And so we can apply our higher order skill sets to add more value to it. And I think that's where the real substance, quite frankly, of the tools really kicks in. It's by allowing humans to do what they do best.
And this is another one for Kevin. So when you're using blockchain for something like government accountability, what do you do about misreporting or errors if the ledger can't be changed?
So it's a great question, and it gets back to what I was talking to, for example, with the voting example. The blockchain itself is incredibly secure. So Bitcoin is a public $100 billion bank vault. It's out there. Anyone who could hack the Bitcoin network, it's $100 billion there today. No one has been able to do that in 9 years of trying. That's incredibly secure. However, tens of billions of dollars of Bitcoin have been stolen at the edges. And so similarly, the fact that information is recorded truthfully or accurately doesn't mean that the information is accurate to begin with. So what's starting to happen is for these kinds of systems, there is the development of various kinds of mechanisms to, for example, create governance. So what does it take to put information on the ledger? And then what happens if there's an inconsistency, if there's some problem with the information that's recorded? And it's possible to build into these smart contracts mechanisms for allowing changes after the fact. And part of the innovation going on right now is figuring out how many of these systems we can automate, for example, by creating incentive-based structures where you can actually create a contract that has an integral arbitration process, where basically there are two parties, they each get a cryptographic key, and then you give a third key to the arbitrator, and it takes 2 of 3 keys to do the transaction. And so that allows that if both parties agree, if there's no dispute about the information, then you don't need the arbitrator, but if there is, the arbitrator can come in. So that's the kind of mechanism that can be deployed here. But absolutely, this is the fact that it doesn't ensure the information is accurate going in. One big reason that I started with that notion that even though these are very real and very valuable public sector applications, just the fact that you can do something with a blockchain doesn't mean that you should, and it doesn't mean that we're yet at the point where the technology is mature enough to do that with a production system.
So this one's sort of bringing together one of our earlier panels on cybersecurity, and it wonders if blockchain has any sort of applications to solve problems with cybersecurity, and if you have any examples of someone trying to do that.
So as with everything else I described, sure, but the question we need to ask is it a better solution? So again, to the extent that I described the Equifax example, if the cybersecurity problem is the data is in one place that is a good target for attack, having a distributed system where there's no one who has control of the data can potentially be valuable for cybersecurity. On the other side, cryptocurrencies are bearer instruments. So if you have the cryptographic private key associated with those records on the blockchain, you're the owner of that information. So potentially that creates an even bigger cybersecurity risk because once you get the key, there's no override mechanism built into the system. It goes back to what I said before, though, about building mechanisms into these blockchain networks that can address those limitations. But yeah, I think at a general level, again, because blockchain systems are based on what the cryptographers call a Byzantine threat model, every transaction is digitally signed. You are assuming that every participant on the network might actually be an attacker, not just the attack coming from the outside. That potentially leads to much better security hygiene, but it also creates new kinds of threat opportunities. So I would say, yes, potentially, But as with everything else, that needs to be something that's intentionally built into these applications.
All right, so I think we have time for one more question. And I encourage you to come down and to the mics if you have some further questions. So there's a restriction on the size of the ledger for blockchain. So it seems how many of the applications is that going to be a problem to, or how is that going to get resolved?
Well, so again, there isn't a blockchain. We talk about the blockchain kind of like the internet, but a blockchain is a network. And there are many different blockchain networks. There also are many, many applications that ride on top of different networks. And again, right now there's experimentation about the technical mechanisms of scaling these blockchain networks, and they make different trade-offs. So for example, Bitcoin was designed for fully decentralized private digital currency. And it trades off performance and scalability for those values. Other kinds of networks are designed for much higher performance throughput, but at a trade-off of some decentralization. And there's not going to be one solution for everything, and we don't even know really what the buckets of solutions are going to be, how many different basic networks and basic protocols there are going to be. So that's early, but there are a whole variety of techniques. If high scalability is a need to make these systems scale. And again, lots of computer science research and also lots of implementation work going on, for example, to create what are called layer 2 networks. So what's happening with Bitcoin is they're building something called Lightning Network, where the Bitcoin blockchain is the basic security platform. And then if I'm doing a bunch of transactions with a merchant, then I can essentially create a private channel that's much more scalable, but that leverages the basic security of the blockchain. That's just one of the approaches that are getting used, and that's a big area where a lot of the investment of companies and people in this space is going.
Okay, thanks. I'm going to welcome up Kent to make some closing remarks. And
thanks again. I mean, why don't we give them one last round? That was great. It's 4:30 on Friday. I'm not going to keep people. Well, let me just say thanks so much for coming. We have feedback forms in your little packets. We'd love to get your feedback. We'll probably follow up with an email as well, what you liked, didn't like, and so forth, so we can improve things. But have a great weekend. And again, thanks so much for coming.